In this video, I'll show you what an impossible event is. I'll show you a few examples of calculating probabilities for events and show you the difference between impossible and zero probability. The probability of an impossible event is zero. In other words, impossible events cannot happen. For example, what is the probability of rolling a 7 on a six-sided die? As the number 7 never appears on the face of a six-sided die, the event is impossible. Therefore, the probability is zero. A certain event is just the opposite. It will happen under every circumstance. For example, if a six-sided die has the number 3 on all faces, then the probability of the event rolling a 3 is 1. Here's how we calculate the probability of an event. We take all of the outcomes we're looking for and divide them by the total number of outcomes. For example, if we have a six-sided regular die, the probability of rolling a 2 is 1 outcome, but we have 6 possible outcomes. That's rolling a 1, 2, 3, 4, 5 or 6, so our probability is 1/6. The probability is the same for rolling a 5. We have 1 favourable outcome and 6 total outcomes, but the probability of rolling a 9 is 0. That's because there are 0 ways for the event of rolling a 9 to happen on this die, but there are 6 possible outcomes, and 0 divided by 6 is 0. Although the probability of an impossible event is 0, it doesn't mean that every event with 0 probability is impossible. There are many situations where an event doesn't happen under some circumstances. In other words, it has a probability of 0 for a certain model or situation, but it can happen in others. Here's an example. Given that a classroom contains all boys, what is the probability of choosing a girl at random? The probability is 0, as we cannot choose a girl if the classroom only has boys. However, that doesn't mean the event of choosing a girl is impossible. Change the situation slightly by adding girls to the classroom, and the probability changes. A final note on the empty set: an impossible event is equal to the empty set. This is a rule of probability which can be formally written as this. If we define an impossible event this way, as a set with no elements, that doesn't correspond to any experimental result, but it's useful in some calculations in set theory. If you enjoyed the video, please subscribe to my channel, and I'll see you in the next video.